UART, or Universal Asynchronous Receiver Transmitter, is one of the simplest yet most important ways for two devices to talk to each other. From microcontrollers to GPS modules, UART quietly moves data one bit at a time without needing a clock signal, making it reliable, low-cost, and easy to use. When UART sends data, it does so in a frame. A frame begins with a start bit, usually a low signal, telling the receiver the data is coming. Then we have the data bits, typically 8 bits representing the actual character. Optionally, a parity bit follows to check for errors. Finally, one or more stop bits, high signals, mark the end of the frame. This cycle repeats for every character sent. For UART to work, both devices must agree on the same settings. The baud rate, such as 9600 or 115200 bits per second, sets how fast bits are sent. Parity determines whether error checking is used. Stop bits, usually 1 or 2, signal the end of a frame. If these settings don't match on both sides, the data will be unreadable. UART is great for simple, short-distance, low-speed communication between two devices. But it's not ideal when you need to connect multiple devices. For that, SPI or I2C might be better. And for high-speed, long-distance communication, standards like USB or Ethernet are preferred. Choosing the right protocol saves time and prevents headaches. Let's see UART in action. Here's an Arduino connected to a computer over UART. In the Arduino code, we set up serial.begin 9600 to match the baud rate. When we type hello in the serial monitor, each character is broken into frames and sent bit by bit to the computer. The computer then reconstructs the characters and displays them. And that's UART doing its job behind the scenes.